So good morning students, welcome back. Today we'll discuss a short technique, short trick to solve the question without using Kirchhoff law. Because some students generally face problem, having problem to solve the question by Kirchhoff law. I will tell you two methods, Kirchhoff law, with Kirchhoff law and without Kirchhoff law. So let's start the numerical. Look students, see, we are given a circuit, this is 4 volt battery, R1 2 ohm resistor, R2 2 ohm resistor, and this is 10 volt battery. Look at students, first of all, I'm going to solve this question by Kirchhoff law. Then I will tell you the short technique to solve this question without Kirchhoff law. See students, with Kirchhoff law, I'm going to look at students, first of all, I'm going to applying current. First of all, you flow the current in circuit. Suppose current always travel from positive terminals to negative. So suppose this 10 volt battery flow provide the current I at this junction, current divided in two parts. Suppose here I1, and here the current will flow as I2. Both will add at this point, and again it become I. In this way, current completes its circuit. 10 volt battery provide current I at the junction, current always divide. We are having 2 points, two ways. So I1 and I2. I1 complete its circuit and I2 complete to that circuit, and again it will add at this point and it become I. So we have to find the value of I1, I2. I1 is a current in 2 ohm resistor and I2 is a current in that 2 ohm resistor. That we have to find. We have to find the values of I1, I2 using Kirchhoff law. So look students, actually Kirchhoff's second law is also known as loop law or voltage law. First of all, I'm going to explain. For the closed circuit means when the switch is on, that circuit having some current. In that condition, the algebraic sum of the potential difference of a closed circuit is always 0. The algebraic sum of the potential difference of the circuit is always 0. That is second law. It is also said to be loop law because it is applicable for closed circuit. It is related to voltage potential. That's why it is also said to be voltage law. So I'm going to apply Kirchhoff's second law in this loop. First of all, this is the first and this is what second. I'm going to apply in this loop. I'm going to give the name of the loop also, A R1 OA. In loop A R1 OA. So we start with A point. First of all, the negative terminals will come of that 4 volt battery. We are reaching at negative terminals. So we'll write -4. Resistance 2 ohm and its current I1. We always multiply current with resistance because another form is what? Sigma E equals to sigma IR. We always multiply current with resistance. So when we come at that side, we started with A point. First of all, the voltage 4 volt, but we are reaching at negative terminals. We'll use minus sign. If we reach at positive terminals, then we use +4. But here the negative terminals comes first, so we'll write -4. And here it's resistance 2 and current I1. 2 into I1. Current multiply with resistance. And again we are coming first with negative terminals of this 10 volt battery. We'll write -10. And this is the final A point. We completed our circuit, we completed the loop, and its potential difference should remain 0. -10, -4, -14, but come at that side it become +14, and 14 by 2 is 7 ampere. So what we got? We got the current in this 2 ohm resistor as I1 as 7 ampere by this long method, by applying Kirchhoff law. Now students, we are going to apply Kirchhoff law in this loop also. In loop A R2 OA. So we'll start with the point A. So let's start. First resistance 2 ohm and its current I2. So 2 into I2. Current multiply with its resistance. And we are reaching first with negative terminals of 10 volt battery. So write -10. And again we come at A point. We completed our loop. We completed our circuit. And potential difference should remain 0. -10 become +10 and I2 become 5 ampere. So 5 ampere is the current. 5 ampere is the current in this R2 resistance, and 7 ampere is the current in this R1 2 ohm resistance. So we got I1 and I2. So this is Kirchhoff law. Students, Now students, I'm telling you the short methods. So see students, what will be the short method without Kirchhoff law? Look at students, for that you have to know the concept. Look at students, this is a 10 volt battery. Okay, suppose this is we are given 10 volt battery. Okay, so this terminal having 10 volt, positive having the value of whatever we are given. So positive having 10 volt and negative always consider with at 0 volt. And the difference, most important thing, and the difference of positive and negative is remains the potential of battery. 10 minus 0, 10. Understood? So we got the potential of this point A, 10 volt. We got the potential at O point, that is 0 volt. Okay. Similarly, this is 10 volt. Look at this is 10 volt. And when we turn at that side, this is 4 volt battery. Let this another point, suppose that is D point. So according to this, what should be the potential at D point? Look at, we require 4 volt. We are given 4 volt battery. It should remain 4 volt. If negative at 10 volt, so this will be, suppose if 14 volt. So positive minus negative, 14 minus 10, that will give 4 volt. So what should be the potential at D point for 14 volt? Because the difference of positive and negative terminal should equal to the potential of battery. Like 10 minus 0, 10. So if this is 10, if 14, so what should be at this point? 14 minus 10, that will give 4. So that's why the potential at D point will be what? 14. So now easily I'm going to get the value of current without using Kirchhoff law. By Ohm's law, what is Ohm's law? V equals to IR. So what should be I1? I1 is V by R. V by R1. Okay students. Look at students. The potential difference across DO. D point having 14 volt and O point having 0 volt. So 14 minus 0. We took the difference. We have to find the current I1. I1 is flowing between D and O. So take potential difference between D and O. Okay. D point having 14 volt and O point having 0 volt. 14 minus 0, that is the potential difference. And resistance is what? 2. 14 by 2 is what? 7 ampere. So look at, we got 7 ampere by applying Ohm's law without any Kirchhoff law. By a short method. Within a few seconds. Okay, by this tricky method. And look at since we can also find, okay, we found already using I1 by using Kirchhoff law. So that is a long method and that is a short method. Look at since we can also find the value of I2. How can we find I2? I2 will be V by R2. Look at since this time. What is the potential difference? A point having 10 volt and O point having 0 volt. So for finding this lies between A and O. So at A and O, difference is what? 10 minus 0. And between A and O, there is a resistance only of 2 ohm. So like 2. 10 by 2 is what? 5 ampere. So we got 5 ampere. So this is the short method without Kirchhoff law, and that is a long method with Kirchhoff law. In competition examination, if you follow this method, you can attempt the question easily within a short period of time. Okay students? So see students, I solved this circuit diagram by two methods. By Kirchhoff method with Kirchhoff law and without Kirchhoff law. When you follow the Kirchhoff law, okay, so you have to follow this long method. And without Kirchhoff law, I solved this question within one line. Listen students, if you know the concept of physics, it will make you fall in love with physics. I like physics so much. See, I solved the question by two methods. Long method with Kirchhoff law, short method without Kirchhoff law. And what we got I1 and I2. Okay, 7 ampere and 5 ampere. I solved in a single line. If you want to attempt the question in competition exam in a short interval of time, we can't apply this method. Okay, we have to apply short method. So we can apply this. If you want to see this complete solution, you can check my YouTube channel. So you will get the solution of complete with this method and without Kirchhoff law. Okay students.